Okay.
Okay. So, Madam is the faculty at Civil Engineering Department at National Institute of Technical Teachers Training and Research, Chandigarh. She has 5 years of industry and more than 10 years of academic experience. She has a master degree in civil with specialization in structural engineering from University of Florida, USA, and is a recognized engineer intern with the New Mexico Board of Licensure for Professional Engineers and additional experience in the project management of highways and building project as well as accreditation of laboratories in India. She has to her credit publication in international and national seminars and conferences and is guiding ME thesis and authoring book on steel design, sustainable building and measurement uncertainty. She has delivered expert lecture in this area in faculty development programs. Her areas of interest include structural engineering, artificial intelligence for civil engineering, sustainable development, environmental engineering, and project and construction management. Advanced computing lab in the department set up by her is focusing on research in various computational and software interventions for civil engineering. Due to her interest in green building, she started the Indian Green Building Council student chapter in her institute. She has also served in advisory role to Chandigarh Pollution Control Committee, Indian Concrete Institute, and is also technical assessor for accreditation of laboratories by National Accreditation Board of Laboratory. With this brief introduction, I request to Professor Himi Gupta Madam to deliver the lecture. Thank you, Madam.
Madam, before that,
Uh, yeah, sure, please.
I welcome our principal, Dr. R.P. Borkar, who has joined. Is
Good
Sir,
afternoon, sir.
sir, or not audible? Not audible.
Is
Yeah.
no,
Now it's okay.
it's okay.
Yes, sir.
Madam, welcome and good afternoon. I am a principal, Dr. Borkar, principal of Government Engineering College, Nagpur. So I officially welcome you and request you to start the session.
Thank you so much, Dr. Borkar, for this warm welcome. And thank you so much, Dr. Sunil and Dr. Revat Kumar. I'm in fact very delighted to be amongst this group today. So I understand this is the 4th day of this Atal program. So there must have been a lot of deliberations already
Right.
on the sustainable construction practices. So without any further ado, I would just start sharing my screen, and I guess I can stop sharing my video so that we can save on some internet speed,
Yeah.
so that we don't have any problem later.
Right.
I hope my presentation is visible.
Yes, ma'am.
Okay. Can I get rid of this so that it doesn't, or will it stay like this?
Yeah. Sorry.
Okay. All right. I'll just keep this here. Okay. Friends, I'll start my presentation today by showing this clip that I came across in one of the newspapers, which is for children, the Times of India for Children. So when I saw this picture, it was really a big concern for me also that, now even children have started understanding that there is something happening with the environment which is wrong, and eco-anxiety is something that the children are experiencing. I think this itself says a lot what where we are headed, what we have already done to our environment. So basically, this is another clip from a newspaper only. So kids are actually, reacting to climate change, saying that, we have, actually done wrong to the environment. We have messed up with the climate and the nature is fighting back through climate change. So, they are actually now understanding, and the it is being pinned to the previous generations, that is us. The next generation is saying that you have actually, degraded the environment, and what you're giving to us is a degraded environment, which is not correct. So again, this is something, you know, which we all have been talking for such a long time, and now our children ourselves, you know, they have started understanding this thing. And we need to understand, you know, that what they are fearing is something, you know, very natural. And this is something, you know, it is not only a health issue, also, you know, it is affecting their minds also. So a lot of things, you know, we need to see not only the air pollution, noise pollution, but these are things, you know, which have started also cropping up. You know, we used to always say, you know, we are doing so much development, but we are, you know, compromising our environment. We are developing so many technologies, but then we are using those technologies to harm that environment itself. And you know, what is the whole use of it? So at the end, I would say, you know, we all say we all, you know, work to give a good life to our children, and now it is very relevant, and it is very, you know, we can see that we are not actually giving them a good life, you know, by we're not giving them the natural resources that they deserve. You know, the environment which we have got, the earth, that is kind of a loan to us, which we have to use, and we have to pass it on to a future generation. But we are not passing them on in the same way that it is supposed we got it. Okay, so I would refer to this another study that was done on quality of life parameters in 2011. I'm talking of. This was also done by Times of India. They conducted a survey across big urban cities of India, 8 of them, you know, Ahmedabad, Bangalore, Chennai, Delhi, Hyderabad, Kolkata, Mumbai, and Pune, which have, you know, a big population, more than 5 million at that time. Okay. So they had, for the quality of life, they took parameters like social infrastructure, what kind of infrastructure is there, school, colleges, hospitals, what are the physical and civic infrastructure like power, electricity, water supply, that had 20% weightage. Then environment like open spaces, sports, cultural facilities, quality of air, you know, all 21% for that. And social and cultural values, you know, how much cultural heritage of the city is being preserved, how is it being portrayed, the woman friendliness, city friendliness, all this, you know, 9%. So these were the parameters with which they did a survey for these cities. And this is, you know, what they came up. These are some other parameters which are also the leisure facilities, commuting ease, quality of life, you know. So they came up with a score out of 5, in which if you see, like the highest score that any city in India could score was 3. Okay, so 3 out of 5. Okay, so just 60%. Okay, so we're talking of, you know, that India is doing so many things developing. But if this is the state that only, you know, 60% score we are getting when we talk of a quality of life, so that definitely, you know, is a concern and something to stop and ponder. Okay, the reason, of course, what we are seeing, that all our forest land, we are just converting it into man-made jungles. Okay, so that is what we are looking at. Okay, we're looking at mega city trends now. You know, we just don't talk of one city. We have cities which are mega city, meta cities, and you know, the world's population is moving towards that, and even India is also on the same trends. We are a developing nation. You know, the entire world is moving towards that trend now. India is also developing. Okay. We also, you know, this was also a news clip which I have included on the left side. Okay. So this is a news, I think from 2020 end sometime. Okay, where, you know, it was published that India is leading the world in pollution-linked deaths. Okay, so again, a little bit concern for us, you know, what kind of future we are giving to our children. What are we doing to ourselves? Okay, and even if I talk of, you know, the number of trees per person, so as compared to all nations, India is at the lowest number right now. Okay, so many countries, of course, they are there, but we are right now at the lowest. Okay, so world has 422 trees for every person, and India is having only 28. Okay, so we need to really think. Okay, I especially included this just to highlight, you know, that when it was COVID times, when it was lockdown and human activities were almost at a standstill, and that time was when nature had actually taken a sigh of relief. You know how nature got purified because there were no human activities. Okay. Now, before COVID lockdown, and during the lockdown, after the lockdown, you know, you'll see similar news you must have come across for related to air quality, water quality, all the indexes that we talk of, you know, environmental indexes. So definitely this shows that human activities are the main culprit behind the environmental degradation. Okay? So, you know, our actions, they are becoming a threat to all the beings on the earth. Okay, whether we talk of, you know, the plants, the flora, the animals, any types of animals we talk of, water animals, air animals, all the polar ice bears, and even to ourselves, as we can see, right? So we are becoming a threat to ourselves also. Okay. So we have to understand that, what we are doing, where we will go next, there is no planet B, although, there are a lot of explorations, there are a lot of movies that are being made these days that, a human race is trying to explore to go to, they show the future, in some years that the earth is completely unlivable, and now scientists are exploring what is the where we can go on some other planet and all this kind of things. So there are expeditions going on for moon these days. Private expeditions have started, commercial ones. So, but definitely we have to understand, to have this whole population, how will we support it if we, degrade the earth? Okay. So that brings us to the next thing, sustainability. Okay, when we talk of a sustainable word, we are hearing a lot. This word we are hearing a lot, but even myself, I think for the last 10 years, I have been also being when I joined this academia. I started. That was the first time I heard about the sustainable aspects, and all. So it was definitely a very good term, and since then I have been hearing about it. But what I feel is that the impact as it should have been, the way we are creating this concept, the way we are having so many courses, the way we are having so many things, trainings going around, still we need to have a very long way that we have to go, that will ultimately start actually percolating to the people, that they have to start changing their behavior also, the way they behave also, that sustainability can be built in. So when I talk of a sustainable society, this is a society where, systematically there is not an increase in concentration of substances extracted from Earth's crust, where there are no concentration of substances produced by the society, like pollutions and all this, where there are no degradation by physical means, like, quarries, landmines, and all those forest degradation we're talking of. But we're talking of a sustainable society where people are not subject to conditions that will systematically undermine their capacity to meet their needs. That is what is happening now. People, that is what we are seeing. The conditions are going that way, that the future generations cannot meet their own needs right now, because we're not giving them enough water, air, clean water, to clean earth to do that. Okay. So basically, when I talk of resources, life supporting resources, they are decreasing, but the demand for the resources are increasing. Per capita consumption is increasing, the population is increasing. We're looking at mega city trends, I said meta city trends. Okay. So again, there is a bottleneck, we have, through innovation, through creativity, through, potential for change, mindset change, we can open the walls of this funnel so that we can ultimately move towards the sustainability aspects. Okay. So sustainability, when we talk, it is a very holistic approach. Okay. So the principles that we go for is, with our construction practices, there should be zero carbon. When we talk of zero, we're talking of a net zero. We have started hearing things about, carbon footprint. So that carbon, the greenhouse gases that are being emitted due to human activities, that is representing this word carbon. Okay, so a net zero carbon, a net zero waste, sustainable transportation, local and sustainable materials have to be used. Local and sustainable food should be used. Water, the natural habitats and wildlife, they have to be protected. The culture and heritage, we have to start respecting local design when we talk of our architectures, our vernacular architectures, all the kind of heritage buildings. Okay. Then trade, health, happiness, they're all principles, and based on this there are 17 goals, also sustainable development goals, which have been defined by the United Nations. Okay. This is another clip that I found. I just thought of sharing, that this is one which is about some schools in New Jersey, how they have started, bringing this change. As said by Barack Obama, the shift to cleaner energy won't happen overnight. It will require tough choices along the way. But the debate is settled. Climate change is a fact. We all know that. Now we can't say pata nahi hai ki nahi hai. We all know it is there. We are experiencing it. I think each and everyone must have experienced it now. And when our children's, look at us in the eye and ask if we did all we could to leave them a safer, more stable world with the new sources of energy, I want to say that we were able to do it. That is where we are talking of the shift to clean energy. So many things are happening around us for the, renewable sources of energy. So that's what we have to do now. Okay. So that brings me to the topic which I have been asked to discuss with all of you, which is the energy efficiency and thermal comfort in buildings. Since buildings are a part and parcel of our life, our 24 hours a day, I think we are spending in buildings only, in our home, which is a building, in our office place, whether it's a school, commercial building, or any, we're going shopping, anything we're doing, we're using buildings a lot. Okay. So it is very important that these buildings, when we talked of those sustainability principles, zero carbon, zero waste, all those kind of things, there are many parameters, So energy efficiency is very important, okay, because buildings are a major consumer of energy. And if we can, tap into this potential, that where we can bring in efficiency into the energy usage in buildings, that can be a very, good step towards sustainability. And at the same time, I would, appreciate the organizers, the way they chose this topic. They also spoke of thermal comfort in buildings, which is very important. When we talk of buildings, we are talking of buildings. They are being built by man to serve the purpose of, have some purpose. Say it is a school building or home building, but at the same time, people should feel comfortable in it. Okay, people should not feel sick in it. A few years back, there was this, thing that had picked up a lot. That was sick building syndrome. People started saying that we feel sick sitting in this building. We're talking of all, glazed buildings, closed buildings, no windows, no outdoor views to see. People are just breathing that, recirculated air conditioner air. So that was the kind of thing which started happening. People have the sick building syndrome. So that's where, this thing started, that yes, what is important, that we also have to understand that the building should be comfortable for people. So there are many parameters for comfort, which I'll discuss with you. Okay. So as I said, buildings are designed for the people. Okay. People should feel comfortable, healthy, and efficient. Okay. So when you talk of an energy efficient buildings, so we're trying to do that, keep the people comfortable. Okay. And also minimize the energy consumption by many means, So it's not that I say for energy efficiency, okay, AC is taking a lot of energy, let me just put it off, and people are just sweating inside it. So that is not the purpose of an energy efficient building. So comfort, occupants' comfort, and minimizing energy consumption is what we are aiming at. Okay. So there are a few parameters for comfort. One is thermal comfort. The thermal part, people should feel comfortable as regard as the temperature, how they are feeling inside. Okay. Another very important aspect is the lighting comfort. Okay, people should also feel comfortable with the lighting part inside the building. Okay, air quality is another important parameter of comfort. The air quality which people are getting inside the building. And another is the acoustic comfort. These are the four parameters. Acoustic means the sound wise. People should be comfortable with these four parameters when they are inside a building. Okay. So basically, when I take care of all these, parameters, okay, when I talk of the building, if I just, try to, make a simile here, if I talk of a building, I would say, I feel it is very similar to me, to a human body. If a human body, if I talk of, if I'm in a very hot place, a very warm, hot place, okay, and if I wear a sweater or woolen, something like that, my body will not feel comfortable. And inside myself, I will start feeling uncomfortable because my skin is not comfortable. My body is not comfortable. So my comfort depends on what encloses my body, which is my skin. Okay. Similarly, for the building to have all these comforts for its occupants inside, the building envelope is very important. That has to be addressed. When I talk of building envelope, what is enclosing the building? The walls, the roofs, the fenestrations, and the foundations. So this is all depending, to understand these things. It is all, very scientific, very engineered thing. There are many physical processes which are happening, which I think we all will relate to our old school time physics classes and everything. There is heat transfer which is happening. There is moisture transfer. There is air transfer. There is light transfer, and all these processes, which are happening, if we can utilize them in a correct way, we can design a building so that it utilizes all these parameters in the correct way, we'll have the comforts that we are looking for the occupants. Okay, so that's what is the concept of a green building. So when it is said we are talking of an energy efficient building, we are also talking of a green building. Okay. So green building, I'll just quickly say, it is a building which is using less energy, less water, and less natural resources. At the same time, it is creating less waste also, and it is healthier for the people living inside as compared to a standard building. So there are similar, parameters which I've already discussed with you. So there are many agencies like Indian Green Building Council or Environmental Protection Energy Agency. They have given many definitions. So they are all tied up to the same concept of having a building which is user friendly, which is environment friendly. Excuse me. So when I talk of a green building, so some might think, although now this concept has picked up a lot, but earlier when this used to talk of green buildings, people used to think that I'm talking of something very expensive building. But the idea is a building, green building, if I compare it to a conventional building, externally it will look the same. The use will also be the same. But the difference will be that a green building will be conserving natural resources. There will be a concern for human comfort and the indoor environment. And there will be operational savings also, as I said, for energy, for water, for all the materials that I'm using. So I'll have a proper efficiency. So I'll have some operational savings also at the same time. Okay. So, almost to the tunes of 30 to 50%. And say if I have to, put in some money or at the first while constructing to have a green building. So I will have all that things in a payback period of some years that it will come back to me in the terms of operational savings. And I'll share this small table, which a study was done by CII IGBC on what are the benefits of green buildings. This was done, very early when new buildings were constructed, which were rated as a green building. The earliest of the buildings you can see here is a Wipro ITC building in Gurgaon, the CII Godrej GBC building in Hyderabad. These were some of the few buildings which were the early ones, pioneers when the green buildings were rated. So they actually did a study on their functioning, and they actually saw that 40 to 63%, savings was there in energy. But of course, you have to understand, depending on the weather, how many people are using, what is the occupancy schedule, orientation of the building, all these things will impact. So the numbers will vary according. So it is a unique number for each building, but at least we can appreciate the fact how much savings are happening. Okay. So there are, apart from this, with this savings, which means direct money into my pocket. If I'm saving on my electricity bill, earlier I was paying 100, now I'm paying only 60. So that 40 rupees is kind of a profit in my pocket. So that's what I have earned. Other than that, of course, there are intangible benefits, as I said. I'm conserving the resources. I'm having good health of the occupants, good daylighting, good air quality, and a good marketability of the project also. Many times we see these days people are talking of corporate social responsibility, CSR. So big companies, they are definitely looking into this aspect, and they're trying to show what they're doing in their building, what they're doing in their companies about this. So definitely it becomes a good point. And since we are also aware of it, so if somebody, if a building is green or something, definitely it will bring, people will have a better feeling about it, Another study that was done on the cost of green buildings, that was at that time to show, that the incremental cost which was there and how many years it could be, payback period was there, and they had that back into their pockets, So from 2 to 7 years, depending. So if it is a big building, it became at an incremental cost of 18%, because it was, this much square area it had. So similarly, these numbers were there. So now there is so much, I would say, from that time to now, there is so much research which is happening. There are so many products which are green now. There is more market demand. There is more, competition. So the prices have definitely gone down. The consumers, they have more options, to go for green products and everything. So these numbers are, of course, far better now. Okay. So of course, when I talk of a green building, and if I have to get for an energy efficient building, my site will do a lot of things. Even water efficiency is something which a green building is talking of. It is talking of energy efficiency, which of course is the focus of our talk today. Then material efficiency is also very important. And there are so many materials which are going into a building, and also the indoor air quality, as I spoke. Okay, so we're trying to have all these kind of things a green building is trying to have. So a site use means the way I put my building on a site. So there should be minimum impact on the environment. The building should go with the site, okay? And also people should have a place where, they have public transportation, they have basic amenities, the construction workforce has all the basic amenities that they require, okay? When I talk of energy efficiency, I'm talking of all the systems, mechanical, electrical, HVAC, heating, lighting, try to have minimum energy. Water efficiency, all the water fixtures, wastewater, water management, all those things in a holistic way. Okay. And materials, construction material, furniture, all kind of materials, refurbishing materials, or decorating materials, all those materials we are talking of, we have to minimize the impact by using recycled materials, by using easily regenerated materials like bamboo, cork, all those kind of things are there, by using materials that will not attract a lot of heat inside. I'll just show you those things also. Then of course indoor environment quality, there are toxic materials with paints, carpets, adhesives, waterproofing materials that we're using. So all these things, we have to take care. There are good products which are available which are non-toxic. We're talking of low VOC paints also these days. So good ventilation, daylighting, they will all help in these aspects. So I would like to now next, this is Laurie Baker. He was a very, very famous architect, a British born Indian architect. So he had taken a lot of initiatives for cost effective, energy efficient architecture, where his designs maximize the space, ventilation and light, and maintained an uncluttered yet striking aesthetic sensibility. So when I'm talking of energy efficient buildings, I would really encourage all the participants to go look up for Laurie Baker and all the projects that he has done. Okay, so even he was inspired by Mahatma Gandhi. Okay, so when Mahatma Gandhi had once told him, a house that does not require any transportation for construction is the best house. Okay, so this is talking of the concept when we said when we always say vocal for local. These days we are hearing that, so use local materials. Okay, so that's something, building practices that we'll see a lot of these things. Okay, so even in his vernacular architecture, Baker used cooling system by placing brick walls which are latticed, the jali systems, the ponds. I'll show you all these things. Okay, so all these using recycled material, natural environment. So all these are the basic architectural principles also which are there. Okay. So now let's since we're talking of heat, as I said, when we're talking of energy efficiency, building thermal comfort. So our building envelope will give us that, and when we do that, we have to understand that there is heat transfer physical process which is happening. So I would just like to draw your attention quickly to something which you all already know. The three mechanisms of heat transfer, which are conduction, convection, and radiation. So conduction is when the heat is moving within an object. Okay, that is conduction. Okay. So if the two objects are touching each other, there will be transfer of heat through the material. Then there will be convection, where transfer of heat will be from one region of a fluid to another because the fluid is moving within. Okay. Then there is radiation, which is the electromagnetic waves through that the energy is getting transferred. Now, if you just think, these are the three principles which are very much applicable to our buildings also, and which is working for the the heating and cooling fabric of our building. Okay, so if I just talk of this, just look into these things. If I have shown this in 3 diagrams here. Okay, so if you see conduction, the building, so through our walls, through our roofs, through that material, so heat is getting in and out, it is conducting. Then through the air which is flowing in and out through convection, there is heat transfer or heat coming in or out of the building. Then directly sunlight coming inside the building, that is through radiation that the heat is coming to. So all these three concepts are very important to understand, when architects, they are designing the building, a structural engineer, when he or she is picking up a material for the building. So all these concepts are very important, where to place the openings, facades, the fenestration. So these three concepts are very important. Now, another, when we talk of, thermal comfort of buildings and everything, another thing to study, of course, is the heat part, So as we all will recall, the total heat which we talk of has two parts: a sensible heat, which is resulting in change in temperature, and there is a part which is called the latent heat, which is the which results in change in moisture content, which we very commonly measure as the humidity of the air. So both these two parameters are very important. With these two terms, I think now you will understand why I have specifically said these two terms. A thermal comfort in the building not only depends on the air being hot and cold, but also depends on the humidity. Okay, so if you are in a coastal area, you'll be constantly sweating. Okay, if we are in dry region, that part is not there because of that humidity, but it will be because of, say, the increase in temperature. So both the parameters are very important. So that is why when we are doing this thermal comfort, these two things have to be studied, the sensible heat and the latent heat. Okay, so also these parameters, they are very important. Okay, so let's talk of heat now. When I talk of energy efficiency inside a building, so the heat which is being generated in a building, or what the heat the building is seeing, there are two types of loads which are there. Internal loads and external loads. When I'm talking of internal loads, loads which are coming from inside. Like all the lighting fixtures. Apart from the light, they are also giving out heat. Okay. Then the number of occupants, our body itself. We are a human body, we are warm-blooded animals, so our body is also generating heat all the time. But depending on my activity level, if I'm running inside a building, my body will generate more heat. If I'm just sitting, it will be lesser. If I'm doing some little exercise, it will be little different. So depending on number of people, their activity level, some heat will be generated from inside, will be heat generated, which will be an internal load for the building to take care of. Then other equipments which are there, all your electrical equipments, they are also emitting heat all the time. Okay, so these are all the internal loads which you can see in this diagram here. Now, apart from that, there are external loads, like there are infiltration, like direct solar heat you are taking, or also infiltration. This is something which is very important to understand. This is, I'll say infiltration, I'm saying this term because it is from unintentional gaps. Say there are gaps in the window and door frames from the wall. So between that gap, there will be constant transfer of heat, and whatever you're trying to achieve inside your building, whether you're trying to keep it warm or whether you're trying to keep it cold, so that thing will get affected because of these gaps, etc. So there are both internal and external loads which we have to take care of when we are looking into the energy efficiency of the building. Okay. So there are the parameters. Let's come to conduction, how it is incorporated inside a building. Now, if you see these diagrams on the left, so inside a building, we have this, say, building envelope, say a wall, okay, which of course has some area and has some conduction property, which we are calling by K, which is the rate of overall coefficient for heat transfer. Okay. Now, as the temperature starts increasing, of course, the temperature inside the building will also increase because of conduction. This material will conduct heat, from out to in. Now, if I have to, stop that, what I can do, one way is that I make the wall thicker. Okay, for the same material, I make the wall thicker, or I can start adding more layers. Okay, I can start adding more layers with different values of this K. So this parameter that I told you, the coefficient, the different layers can have different coefficients also, or I can go for a thicker layer. So conduction, if I talk of heat transfer through conduction, that is directly proportional to the area, and then there is a heat transfer coefficient and the temperature difference across the two things. Now this parameter is definitely has to be regulated, and this is I will talk about it. This is ECBC, which is, we're talking of Energy Conservation Building Code. So they are trying to regulate this U factor when they're trying to say how you design your energy efficient buildings. Now, definitely depending on the type of climate where the building is located and all, so all these materials you will use accordingly. Okay, so this is what I'm talking of, the different wall properties, as I said, the different materials. Okay, so we have a U factor when you talk, when you go and buy these materials, these are the properties you should be looking at, U factor, which is the overall conductance of the building. Okay, so that is telling us, how much, heat is kind of flowing. Then there is thermal resistance, as the name says, which is the inverse of this U factor, which is what is the material's ability to resist the heat flow. Okay, so of course there are the metric terms which are associated with the units, which you can always see. So now these are the kind of things we are trying to regulate. Okay, now if I talk of another important things for building envelope, like fenestration, which are the openings, another very important term is the solar heat gain coefficient. Okay, so that is measuring how much of the incoming heat from the sunlight it gets transmitted into the building versus how much is reflected away. So definitely when the light will come in, okay, some will get transmitted into the building and some will get reflected. So solar heat gain coefficient, which is the HSGC. Okay, so that is trying to measure that. Then there is also a parameter which is very important, is the visible light transmittance, which is the VLT, okay, which is the fraction of visible light which is passing through a window or glazing. So that is VLT. Okay, so it does not measure shorter wavelength light like UV or longer wavelength light infrared. It is only measuring the visible light. Now this is very important when we're talking of daylighting. We want to have daylighting inside the building. So these parameters, they are very important. Okay. So this is like, as I said, by increasing the, layers of different materials. So if we have air cavity, definitely air cavity is another. Air is known to be a very good insulator if it is packed inside there. Okay, so that will reduce the solar heat gain factor. Okay, and performance is improved if the cavity is ventilated. So heat is transmitted through the air cavity by convection and radiation. So, with all these combinations and all, I just want to give you a little idea. Using different materials, we can achieve a lot of things with regard to the thermal comfort inside the buildings. Now coming to radiation, this is as we already have studied SHGC, so directly related to that factor. Okay. So this brings me to another very important term, which is the solar reflective index, SRI, or the solar reflectivity. Now this is a very important parameter, because when we are talking of material which we are applying on our roofs or on our walls, so if we are basically in a very hot climate, okay, we won't try to use dark colors, because that will attract more heat, that will absorb more heat. Okay, we like to have materials which are reflecting solar. Okay, so that is two parameters which you all must read these, which is the solar reflectivity R called, and solar reflectance index, which is the SRI, which is also depending on the color. Okay, so even companies like LEED and everything, so they are using these kind of parameters to see what kind of material is being used for roof. Okay, like to meet LEED requirements, which is one of the agency which is certifying buildings for being green. Okay, so they require a roofing material to have an SRI of 29 or higher if the slope is very steep, which is greater than 2:12, and SRI of 78 or higher for low roof sloping. Okay, so this kind of parameters, they will always help you in designing your building envelope. Okay, so I just pulled out these numbers just to show you, depending on the color of the tiles and all. So the values of these factors are basically given. So definitely when we're trying to design a building in an engineered way for energy efficiency, if we can do a little research into the materials and these values, so that can help us in designing them. Okay. Another very important concept, when we're talking of building envelope, is the thermal mass. Okay. So thermal mass, of course, we all know, that can be very helpful, because the thermal mass is having the potential to store heat inside it. Okay, so definitely it is directly proportional to the density and specific heat. So as this diagram is showing, okay, so during the day, that how the external temperature is like this. Okay, so if it is going in the day, it is going up, night it is going down, again day it is going up. Okay, so if you have a very internal temperature, when you have low thermal mass, so that temperature will also go side by side. Okay, kind of there will be a little lag, of course, because through the thermal mass the heat has to infiltrate inside the building. So the peaks and the low peaks, they will come a little later than the outside temperature. But when I talk of a very thick high thermal mass, a thick wall or something, that time the peaks, they will be delayed by almost 6 hours. Okay, so that can definitely help. The daytime, when the sun is at its peak between 12 to 3 p.m. If you can delay it by 6 hours or something. Okay, so that can definitely help, because by that time it will be night and the cool air will also start flowing in from outside. So that can help you in designing a building which is there in say a very hot climate. Okay, so even the difference is there. The thermal mass, even 6 to 8 degrees Celsius drop in the temperature is there. So even you can reduce the amount of heat which is coming from outside. So thermal mass can also play a big role by having thick walls or something like that. Okay, that's what we're talking about. Okay. Now what this is showing is again one example for roofs. How, since roofs is another part where there is a lot of heat ingress. Okay, so they receive most heat throughout the day. Okay, so a very important aspect of our construction practices as the roofing material, I've already told you about the SRI tiles and everything. So especially when we're doing air conditioning, so it is very important that what we do with our roof, So this is showing a lot of solutions. There are cool roof technologies which are there. Like this technology, they are showing, they're putting some insulating materials on the roof. They're doing vegetation on the roof, as you can see, or you can put, proper tiles which reflect most of the solar radiation. So all these kind of solutions can help with the roof also. Okay, so as I said, our walls, our roofs, our glass or the glazings, the fenestrations, which are the openings, the shadings, very important. We're talking of louvers and everything. I'll show you some diagrams also later. Skylighting, all these things can help us in saving energy. If I'm tapping into daylight, I won't be using artificial light. So that will also save energy. Okay. So coming to more passive techniques, which I would say is the orientation of the building. Now, if I orient my building in such a way that I harness the solar energy based on how the sun moves, so if I can harness that with the way my building is oriented, I can control what amount and what type of heat is coming inside my building along with the light. Okay. So I've already told about brick walls with insulation. We can use glass wool stuffed thermocol, extruded polystyrene also, air cavities, then hollow blocks, fly ash bricks. Then there are AEC blocks, which are getting so popular these days. Then for roof insulation, we can do over the deck, we can do under the deck. Then there is insulation which is sandwiched also. Okay, we can go for high albedo roofing material, roof cardan, and as I said, for the glass, we can go for low U and low U glass and glazing. We can have thermal breaks in terms of air, argon gas, as you have seen, double glazed, triple glazed window panes which are coming these days. Okay. So this AAC blocks, it has good thermal properties. Okay, very less reduced time and cost for installing boards, also better U value also. Okay, so all these type of materials, they are being promoted these days. Okay, there are a lot of new interventions also which are coming up, which are just included. This is something I came across a news clip. Where researchers in US, they have created a super strong wood material that can remain cooler than its surrounding temperature. So they have used cellulose nanofibers, okay, and they're saying the mechanical strength is also stronger than steel. So they are the testings they are doing it. So definitely we can see, they're saying that on average 5 to 6 degrees cooler than the ambient air temperature. So that can be, very important. Okay. So also some Sweden-based scientists, they are developing this transparent wood that can store and release the heat. Okay, so kind of a good technology. Okay, so it is good for solar cells. It will be cheaper, that they're saying. So you can always hope for this. This is one thing which I included. Showing sustainability aspect, appropriate technology, I would say. This was a disaster example of a disaster hit city in Philippines, Binan city. So what they had a disaster wherein they had a volcano, and what they did was they used the volcanic ash to make bricks for the city. So this is something, a very sustainable thing. What was a waste for them, they converted into a building material. Okay. Okay. So again, thermal comfort, coming to the definition as per ASHRAE, okay, it is the condition of mind which expresses satisfaction with the thermal environment, and it is assessed by subjective evaluation. So definitely thermal comfort will differ from person to person. Two people sitting in the same room, one might feel more thermal comfort as compared to the others. Like one may be comfortable with a AC at 18 degrees C, one may be comfortable at 24 degrees C. That's why they said it is a subjective evaluation. Okay, so what kind of satisfaction your mind is saying as compared for the thermal environment. So of course, as I said, personal factors will be there, activity level, clothing level. Somebody is very heavily dressed, they will feel more hot there. Okay, so activity level I already said. And of course, then there will be environmental factors also. What is the ambient temperature which is of the room? Okay, then radiant temperature, what is the humidity, what is the air velocity? All these factors will also have an impact on the thermal comfort. Okay, so our India, the ECBC, they have divided India into 5 climatic zones. Okay, the whole idea to understand that each building in each zone will be designed differently. If you're trying to build a building, say in this cold and cloudy region, if I'm talking of this north region, here my to make a thermally comfortable building, my aim will be that because it is very cold region, so inside you need to keep heat inside. So you have to maximize heat gain and you have to minimize the heat loss here, as compared to when I'm talking of a building which is in hot and dry region somewhere here in the Western India. Here your aim for thermal comfort will be to keep it as cool as possible, completely reversed from this zone. Okay, so here thermal comfort parameters will be different. You have to maximize the heat loss and minimize the heat gain. Okay, so similarly, that's why they have divided that there are 5 zones. So accordingly, where the building is located, it should be designed. The principle should be according to that for a thermal comfort. Okay. Now, this is one of the charts which I have pulled up from the ECBC only. Okay, so how they are, directing to design this thermal comfort. Okay, so there are charts for indoor operative temperature versus the mean monthly outdoor air temperatures. Okay, so how, if it is 80% acceptability, 90% acceptability. So when architects, they are designing, or your, HVAC or electrical engineers, they are designing the systems, they can refer to these charts. So based on, the time, the maximum operative temperature change allowed. So, how much acceptability you can, within this region, you can design your buildings like this. Okay. Another very important parameter that is studied for thermal comfort is the psychrometric charts, okay, which is a chart for temperature versus humidity. As I said, thermal comfort is a combination of both of these, temperature and humidity, right? So definitely there is a zone which has been identified as a comfort zone, okay, so which is a combination, right combination of temperature and humidity, where the people will feel comfortable. So when you're designing, based on your site, based on the outdoor temperature and humidity, you have to design your building. So definitely you will fall in some region, and accordingly, you can take measures that if you're somewhere here, if you have to go towards this side, you'll have to, work on your sensible heating. If you have to go in this direction, you have to go for heating and humidifying, or humidifying. Okay, you have to increase the humidity, or you have to go for evaporative cooling, which is another technique. With evaporation, it cools the environment. Okay, then sensible cooling, if you want to move this way, you want to do cooling and dehumidifying, or dehumidifying, chemical dehumidifying. So there are many techniques. So based on the site on which your building is located, you can take various measures after studying this psychrometric chart on what kind of measures you need to take in your building to ensure thermal comfort. Okay. Then also the climate data, that is very important. So because a building will be located at a site, there will be, the climate, the weather, that will be changing. So it is very important to study, the dry bulb mean temperature, wet bulb mean temperature. Okay, so that is very important for passive heating and cooling designs. Okay, because the variations will be there during the day also, during the year also. So we have to record all these kind of things. These are studied. Okay, so dry bulb temperature is the air temperature, and bulb temperature is the air temperature that takes cooling potential due to evaporation into account. Generally, relative humidity is indicated by the dry bulb and wet bulb difference temperature. Okay, so these kind of studies are also done when we are trying to design a building envelope and everything. So what are the variations of the climate throughout the year or that? Okay. Another very important aspect to can I just hide this? Okay. Yeah, another very important aspect which is studied is the sun path and solar position. It's very important, when architects, they design the building, they actually study these things so that, there is good thermal comfort, because you're trying to, sun is something which cannot be avoided, it is there. So how you will design your building with the sun? So if you know its path, so people study, as the sun position, the altitude, azimuth, these are the various positions, vertical and horizontal, how the sun's path is varying throughout the year. Because, it is known that in summers, the sun is always high, and it rises and sets north of the east-west. Then in the winter, the sun becomes low, and it rises or sets south of east-west. Okay, so with these kind of, this kind of knowledge, the building can be oriented in such a way, the openings can be given in such a way that how you can, shading devices can be, drawn. And there are, some important dates that are definitely studied, like 22nd December, 21 March. So these are things which, very important as compared to for the sun path, that sun is at the highest moon altitude, or it is, at the lowest. So all these kind of studies are done so that in all throughout the year, the building should feel comfortable. Okay, so that natural heating, daylighting, and shading techniques can be incorporated. Okay. Then, if I talk of visual comfort, that is also very important. Okay, so natural lighting can help us. Artificial lighting can help us. Okay, so definitely when we are talking of lighting, we have to give an ambient lighting, which is the overall lighting, and some specific task lighting should also be there. So then only people will feel comfortable. Okay, so visual comfort means you have to give the right amount of light and also the right distribution of light. So a glare definitely is not a comfortable thing, which I'm showing you here. This is from natural sun, how it is causing glare. Glare comes when adjacent low and high brightness areas are there side by side. So that causes glare. So we have to look into this aspect also. With lighting, we should not be there, should not be glare. Okay, so visual comfort is very important for well-being. This is now being studied that it is not just about buildings. Even people feel better when there is good visual comfort. Well-being, healthness, well-being, these are the terms being associated. Okay. So this is just I just want to show how daylighting can be tapped into the buildings. So studies can be done with the proper designing of your windows, light shelves, if you can give high windows. So you can see even on a day the study has been done 2 p.m. 6 p.m. there is adequate daylighting inside the room. So with daylighting itself, we can do a lot of things with different things like light shells. We can give light wells like this. We can do skylights. So all these kind of things can help us. Okay. Because daylighting, of course, we have to understand it comes with heat gain and glare also. So we need to have a balance between that thing. Okay, we want light, but not too much of heat. So definitely, as I said, materials can help us with the U, R values, all those SHGC values. Okay, so we have to look at the window wall ratio. Okay, how much windows we are giving as compared to wall. Okay. So very important. This diagram here, okay, that's what it's showing. So window wall ratio, if it is 10%, this is the heat and light gain. Okay, as you keep on increasing the window, you'll of course get more and more inside. But again, you need to have a balance. Now, what this one is showing is, there is an opening and some kind of blinds have been put. Now, if you put a blind inside, now what is happening? You've already made the sun enter inside, and now it will definitely get distributed some way or the other. So it's always better to stop the sun from the outside. So external blinds are always better. So stop it from entering the room, stop it outside itself. Okay. Then this one, as I said, the winter sun is lower, the summer sun is higher. So, these kind of eaves which are doing the sun shading, they can help you in both ways. In summer, they will help you because the sun will get reflected. It will not come inside. In winter, when the sun is low, it will be able to enter when you want to building to heat up in the winters. Okay. So then this is talking of, all various things, how you can have smaller south facing windows, well insulated walls, even floors, carpeted, all those kind of things. Okay. So all these parameters are to be studied when we're talking of thermal comfort. Then talking of artificial light, there are many things which are there. Incandescent lights are there. There is electric discharge, gas discharge equipment there. LEDs are so energy efficient and famous these days. Okay, so everyone is using them. Now this is also talking of another shading system. As the sun is, as it's also showing that how with winters the sun is going down, and so the shading system. These days there are mechanical shading systems. Which can be controlled how much you want to have. So it is, this one is showing full up. Then there is position 1, 2, half down, 1/4 down, 3/4 down. So with these kind of technologies also you can keep on regulating how much sun ingress is there. Okay. So of course, lighting, we have to look into all our fixtures. They should be energy efficient. Okay. We can go for, we can minimize human control and have more of, sensor-based technologies can also help. LEDs are better. Okay. So those kind of things can help with the lighting. How lighting can lead to energy efficiency. Okay. So definitely lighting fixtures, they should be according to the usage. If close to a window, we can have less lights on. Away from the windows, more lights can be made on as compared to close to the window. Have occupancy sensors. Okay, so based on occupancy, motion sensors, or all those pressure sensors. So accordingly, the lights can get on and off. Okay. So as much as possible, I've shown you how you can utilize daylights, okay, artificial light and daylighting at the same time, okay. So definitely there are so many things which are there. So CFLs, T12, T8, T5s, and CFL came. Then now LED. Now we are talking of electronic blast technologies. Okay, so a lot of things. High output LED, inductive lamps, sulfur lamps, nanocrystal phosphor sensors. These things are all coming in lighting. Okay. So energy efficient street lighting is also one part when you're talking of energy efficiency in buildings. Okay. So we have to see that we are not, causing light pollution, that wherever the light is intended, it should be thrown there only. So not have unnecessary light 360-degree around, okay? So all those kind of things, they are important. If they can use solar, all those things. So energy efficiency will be definitely achieved. Automatic shut off, okay? Minimizing light pollution and glare, as I said, proper cutoff, light distribution, okay? A good color rendering, high lumen maintenance, cost effective. So all these kind of things are required. Okay. Now, as we say, glasses also, we're putting glasses in our windows and everything. Of course, we want windows, but then glasses, we have to understand with the light will come heat also. So glasses also have to be looked into. So double glazed windows, as I said, they have polyester sun films, or they have, thermal breaks like air insulation or argon gas, all those kind of things, double panel, triple panel. So they are also helping in, achieving this kind of energy efficiency. Okay, high performance glass is just called. Okay, so it lowers the energy consumption also. Okay, so this is one example of a triple glazed units. Okay, so they have a thermal properties of conventional brick wall. Okay, so they have low emissivity, so they are called almost like transparent wall. Okay, so they bring enormous lighting into the office spaces with less heat ingress. Okay, so definitely a very good solution. Okay, so you all can look this up. Okay, how it is being used in buildings. Okay, so when I have to optimize energy use for visual comfort. Okay, so visual comfort I have to have, and it will take energy. So I have to have a balance between the external factors and the internal factors. So external factors like climate, daylight availability, building site and obstructions. Then there will be internal loads, okay, like my fenestrations, room surfaces, occupant behavior. So I have to strike a balance between these so that I can have active strategies like energy efficient lighting and lighting controls, and passive strategies like proper orientation, skylights, light shelves, reflectors, as I showed you, fenestrations, light transport systems. All these factors have to be then looked into. Okay. Now another part when I talk of thermal comfort is air. As I said, air will also play part in the energy efficiency and thermal comfort. Okay, because moving air, it always cools because it accelerates the heat transfer. So it is of very good interest when I talk of ventilation. So ventilation is definitely, a good thing. Natural ventilation, we all like breathing fresh air, good air. Okay, so for that, it is the study of windrose diagrams which help in studying the understanding the speed and direction of wind on a site. Okay, so that's very important. Okay, so windrose diagrams are studied for that part when a building is being planned. Okay. Now there are various things which can be done for promoting natural vegetation. Like on the site itself. If my site, I can have trees which can help in either bringing wind into my site, or if not desired, I can even deviate wind outside of my site also. So trees can help. What you can see here are long trunk trees and low trunk trees. Okay, so how they can help in having a wind inside the site, deviated inside to the site or away from it. Okay, similarly you can see examples here. How tree foliage it can help. Here this is the building I'm talking of. Having foliage here will of course put all the wind inside the building. Okay, if I have this example where the opening is here in the building. Okay, and I have such a tree which is having very low trunk, so definitely it will deviate the wind like this. Okay, so if I want that, I can have that. Okay, with a low tree I can deviate all the wind inside. Okay, this is another example. You can see how with the position of your natural landscaping and your openings, so you can actually have a little control on how the air is getting inside your building. Okay, So this is another example, where trees with large foliage, they have trunks bare of branches up to the top level that you can see. Okay, so they deflect the outdoor wind downwards and promote air motion in the leeward portion of the building. How it is promoting airflow here, and that is helping in, regulating the temperature of the building. Okay. So more pictures about now, more concepts, I would say, for natural ventilation to promote that. If I, align the shorter axis with the prevailing wind, it will maximize the ventilation. If I'm doing my wind like this, shorter axis with the prevailing wind, I will be maximizing the natural ventilation. Some more concepts, basically cross ventilation is always better, and we should try to fill up the whole space. Okay. So with a single opening like this, I'll be, reaching about 60% of the space. This is also, you can see what is happening here with this kind of opening. But this is a cross ventilation where I have reached this much of space. Now this kind of ventilation, okay, this is adjacent. Cross ventilation is reaching the entire space. So, with different techniques of how you place your openings, the design of these openings, you can see all these diagrams. So we can regulate how much natural ventilation we get. Okay. This is another concept, if I can pair a small inlet with a large inlet, so that will also increase the ventilation. Okay. A natural thing how air will try to flow from a small to a larger place. So it will be like a suction kind of thing that will try to do. Okay. Now, when I talk of tall buildings, you can see the effect, with tall buildings, how I can promote more ventilation and less of heating risk. Okay. So yes, you see both of these. Okay. Then of course there is also the stack effect, which we are all aware of, with stack, how air is one of the thing which is important for us, and how we can play around with its properties to have the stack effect. So this is showing, a solar chimney, wherein you can have a stack effect, and all the air will start getting circulated because the heat is falling on this part. This area is getting heated up, so it is sucking all the air from this room, and that's where the air will start flowing, and you will achieve ventilation. Okay. So solar chimney, there are so many things which can be done like this. Okay. Coming to more passive architectural techniques, for promoting natural ventilation or having, cooling or passive heating cooling effects, jalis and jharokas, they are like, they moreover serve like the air can be, just flow through it in a brisk way, and inside can be cooling effect. Then definitely water bodies, they create a microclimate, so evaporative cooling concept we are aware, so that can create cooling effects. So both these techniques are very popular, in the dry areas, the hot areas, they can be very helpful. So you're seeing examples that only. What you see here is the Hawa Mahal Jaipur, and this is the Fatehgarh Sikri, Jodhpur side, that's Agra side or somewhere, So all these are hot places where they are being used. Okay. Another passive architectural techniques, recessed windows. The windows are recessed. So what we are seeing is an example of Delhi, which is seeing both hot and cold climate. Okay, composite climate. Okay. So the windows have been recessed. If you see the windows, these are the windows. They are recessed. They are inside. The sun is not directly falling on them. So this concept of corridors, verandas, they help in this kind of regions. Okay. So now another very important part is when you talk of electric energy efficiencies, HVAC, because heating, ventilation, air conditioning systems, they are very important. Okay, so we are using almost 6 to 8 months. They are being used for the thermal comfort of the occupants. So they are a very significant number for energy consumption and cost. Okay, so we have to address that part also. Okay, so definitely, in big buildings. Okay, so we have chillers. Okay, there are air handling units, there are pumps, there are cooling towers. Okay, so they have speeds and all those things. So we can reduce the energy consumption there by having a proper design. If I can, there are parameters like coefficient of performance. If I can have a high number for that, which is the ratio of heat moved divided by the energy used for that equipment. So high COP can help in having energy efficiency. Okay. Then just some principles for HVAC, say thin buildings, they lose more internal heat to the outside. Okay. So you can see both the concepts here. So when you're designing your HVAC, your building shape will also play some role. So this can be kept in mind. Then there are also concepts like night purge ventilation, which is the night flushing. If you keep your windows and other passive ventilation openings closed during the day, but if you open them at the night, So that will flush the warm air out of the building, and the thermal mass will be cooled for the next day. So that is also helping in your better HVAC. Okay. So this is another concept of Trombe wall that I've already shown you, how with stack effect I can keep, flowing the air inside the room like this. Okay. Then people are also using, geothermal techniques, because, if you go about 4 meters down the surface, okay, the temperature of the earth is almost constant at around 27 degrees Celsius, no matter what is the temperature on the surface, 4 degrees or 40 degrees or 50 degrees. So if you can have, pipes which are circulating air from below the earth, so hot air coming here becomes 27, recirculated, from here it is taking outside air and recirculating into the room. Okay, if it is cold air, make it 27, take it to the room. So these kind of loops are also being, ground loops are also being used. Okay, so we can have a lot of things, other energy saving measures. Say I'm talking of big buildings, I can have level controllers for overhead water tanks, the pumps and all which are being used. So if we can decrease on that, energy efficient lifts with group control. I'm talking about multi-story buildings, I can have some lift controls. Say I know that, a lift, whenever it starts or stops, it takes a lot of electricity. So if I can, work on that part, say I know a building, group housing building, multi-storied. So morning 8 to 9, there will be a lot of use of building because people are leaving for office. Then evening 6 to 7, there will be again a lot of use. So if I can, have some lifts, rather than having them stop at every floor, if I can have, dedicate one lift for odd number of floors, dedicate one for even number of floors. So this can, kind of reduce the unnecessary stop. And so just giving some example, these kind of things can be done. Okay. Even water pumps, motors with high efficiency, they can help. Okay. So this is just one example, how if we can go for a effective electric motor, how it can, help in saving energy. So definitely this is one part. Wherever we are using electric motors, must have a look at it so that we have higher energy efficiency. Okay. And of course use CFC free appliances, all the energy appliances that we are using, okay, easily available these days. Okay. So energy performance, it has to be a holistic approach. Okay. So what type of materials I've already shown, they also help in that way. Okay. Then another very important aspect is the controls and building management systems. Okay. Now I put the best of equipment, I give the best, technologies, electric motors, sensors and everything. Okay. So, but also if it is not used in a wise way, then it will not serve the purpose. So building management system is something which can definitely help. Having some controls, automated controls, so that, you are decreasing the human intervention where there are chances of mistake. If you have automated things, they can help in much better way. So automation of building services, minimized human interface, I can have centralized control. I can use intelligent gadgets. There are so many things these days which are available. they're becoming more and more cost effective as the demand is increasing. So all these things can definitely help. Okay. Even, for this heating cooling system, there are many systems which are available for a chillers, pumps, fans, lighting unit. You can do online corrections, interactions, to see that energy usage is optimum. Okay. Then because variations, of course, will be there in load, in occupancy schedule, in climatic conditions. So these can all be, looked into in an very automated fashion. If you have everything connected to sensors, there is a centralized system, an artificial intelligence system which is looking into it. Okay. So if you can measure those things, you can have verifications, data generation and updating. So these things can be designed properly then. Okay. So of course, definitely commissioning very important, having the best equipment, but of course it should be also used in a energy efficient way. Okay. Now for all these kind of things, building energy simulations are very helpful. Okay. So basically, the idea is I have to manage my energy consumption in the building. So I have to measure it first. If I'll be able to measure it, then only I'll be able to manage it. So again, before the building is constructed, so whatever necessary modifications are required for energy efficiency, all the parameters that I spoke of. Okay. So studying the sun path, putting in the climate data, putting the windrows diagrams, what will be the occupancy schedule, daily, hour wise, then week wise, then month wise, yearly, So accordingly, these building simulation, the softwares, they can give you a lot of knowledge of what will be the energy usage in the building. So, playing with these parameters, changing them, you can design your building accordingly before construction, so that when it is constructed in a way that it will be energy efficient. Okay, so all these kind of factors will be taken care. There are many softwares which are available these days, like eQuest and all. So some are even open source are also there. So, and there are many, companies also which are doing these kind of consultancy work for doing building energy simulations. So, many government sector buildings, they are planning in a way, new buildings that are coming up, they are already going for building energy simulations before constructing them. So, lot of awareness in this part. It is definitely, I would say, since you all are teachers, this is something where we can guide our students also as a very good, employment opportunity, a very good career in terms of building simulations, energy simulations. So there is a lot of scope for our civil engineering students also there. So input going is building envelope, HVAC, you have to give all the properties, the U factors, HHGC visible for the windows, wall, roof, floor. Okay, accordingly it will calculate, how much heat will come and go out. Then HVAC, what type of we will be using, mechanical or what, and then heating and cooling, what will be the schedule, energy source. Then service water heating, okay. Then other equipments which are there, activity schedule, lighting, all the operation schedule, luminaire types, radiation, auto control, LPDs. So with all these input data, the software will be able to calculate the energy usage of your building, during peak hours, less hours. It will give you all the numbers and you can optimize those things then. Okay. So like this, it will show you a lot of things, as I said, month-wise, it can show you that a lighting area will take this much of energy, miscellaneous equipment, ventilation, cooling, these kind of numbers will come up. Okay. So since, I've been saying about ECBC, so this slide has come a little late. So this is something, recently PEDA is the Punjab Energy Development Agency. So ECBC basically is a national code. So that is on energy conservation building code. What I have included here is a snap from a presentation by PEDA, which was given in our college. Okay. So basically ECBC is a national code. In 2017, they had revised it. Now, basically the idea is the ECBC talks of, how to create a net zero energy building in India. Okay. So basically each state, because as we've understood, there are different climatic zones. So each state, according to its climate and everything, if they want to make some modifications in ECBC, they can make that modification and then implement this ECBC, and it is notified then. And everyone then as a law have to make the buildings according to this ECBC. So there are many states in which already they have modified according to their requirements of the state in the terms of weather and climate conditions, and they have notified it. So Punjab is also one of the states. Since I am from Punjab, so I'm quoting that example. So latest version is 2017. Okay. So it is applicable to new commercial buildings which connected load of 100 kilowatts and contract demand of 120 kVA. Okay. So basically, this ECBC is trying to, promote a thing like 3 levels of energy efficient buildings. One is ECBC compliant, one is ECBC plus, and one is super ECBC. Okay, so I'll just show you what these are. So the target is that we have to save 30 to 50% energies in the design and construction of new commercial buildings. Okay. So basically what they're trying to do is, even if you have a new building, okay, or even when you're going for an alteration or addition to an existing building, okay. So if you're going to get renewal of connected load due to addition or alteration, so eventually if you're going to meet these numbers, you will have to abide by ECBC then. Okay. So again, the exception is that buildings that do not use electricity or fossil fuels, they can be exempted from ECBC. Okay. So then equipment and portion that use energy primarily from manufacturing processes, or say when this code is in conflict to the health, safety and environment codes, then maybe those codes will prevail. But otherwise, once ECBC is notified in a state, it has to be abide by. I think even in Maharashtra, this is already notified. Okay. So this is, when we're talking of an ECBC compliant, building, so they're talking of all these parameters which I've already spoken to you, solar water heaters to be used, so that heat recovery, at least 20% of the hot water that can be done. Then they're saying use condensers, okay, such that heat sink is free of interference, all these condensers for ECs, okay. Then energy efficient luminaires, lighting control, wall with low conduction, I've already spoken about that, skylights, okay, energy efficient HVAC, okay. Then all these skylights, the glazing, VLT, SHGC values you must control, okay. Then the glazings, okay. Then you have to monitor and meter all your energy consumptions, okay. As I said, if you measure it, you will be able to manage it, okay. Then of course, also we are talking of all these transmission losses, the distribution losses, so they also have to be looked into. So you have to go for energy efficient transformers with low power losses, okay. Distribution losses not more than 1%, okay. So all these things compliant can make an ECBC compliant building, okay. So when I'm saying ECBC, ECBC plus and super ECBC, the amount of energy that you will save from 30 to 50, the more you save, you're going towards super ECBC building, okay. So of course, even Bureau of Energy Efficiency, so they are also having a program wherein they can rate an existing building on what is its energy performance index, which is how much energy it is using, okay. And another thing, since ECBC is more for commercial, for residential also now recently the government has launched this energy conservation building code for residential building, which is called ECBCR, also called the Eco Nivas Samhita. Okay, so ENS is how it is very commonly known. Okay, so I would encourage all the teachers to please look into this aspect and also teach our students for the future, civil engineers, architects, mechanical engineers, electrical engineers, that they should know about all these things. So when they go into the field and design the future buildings, okay. So there are many reference guidebooks which are also available on the BE website, which can be referred to. I'm just showing all those to you. So of course there are, new inventions, innovations coming, interventions, like some scientists, they are developing this material which is heat insulating and heat conducting at the same time, they're saying. So these kind of things are coming up, This is one example of a city, okay. I think it is Singapore. Yes, it is Singapore. You can see how what they're doing. The government has integrated the system of all the smart city technologies for utilities and waste in large underground tunnels. So they are using their underground land now, okay, underground. They are using to have all the cooling towers, cooling plants, thermal storage tanks, all these things. They have put it on as a smart city concept. They have all integrated this and everything is underground, okay. So as I said, metering is very important, okay. If we can measure, we can know how much we're using, how much we are saving, okay. So that is very important. Even solar water heating systems, okay, solar is very much there, okay. So these days we are going for building integrated photovoltaics, okay. So basically the building envelopes such as roofs, skylights, facades. So instead of using conventional materials, directly photovoltaic panels are being installed, okay. So they become the building envelope itself, okay. Typical, so solar pumps are coming up, solar flashlights. There are so many things, Tesla recently it unveiled its latest version of solar roof, okay. So this is, if you can see, these roof is entirely made of solar panels, okay. So just think of how much it can do. This is another one which is bifacial, okay. So they have a high energy, okay, yield, okay, high reflectivity also, okay. So very high energy they can produce, okay, even at large elevations, okay. Then there are net metering concepts which many governments are giving. In Punjab, definitely it is there. So basically, if you're having renewable energy that you're doing at your site, so whatever you want to use, you use. If you have extra, you give it to the grid. Okay, whatever extra energy you have in terms of solar that you have generated at your site. So whatever energy you give to the grid, your electricity bill will get reduced accordingly. So that's a net metering concept. So many things are being done, especially for solar. So many things are happening. AC/DC conversions have been eliminated. People are directly using, to power lights. Many things have been demonstrated in IIT Madras campus also some years back. So, so many things are happening. Even this MNRE, which is the Ministry of New and Renewable Energy, they are constantly monitoring all these, solar. They have set up stations so that, they can properly design the infrastructure according to that. They are gathering all this data. Okay. So these are just some new things which are happening. This is one example, Cochin Airport. They have installed floating solar power plants. Okay. In Rewa, the Asia's largest solar power plant has been inaugurated in Madhya Pradesh. Okay. And at the same time, since solar energy, another important aspect is because sun is not constant, there are cloudy days, there are nights, and also it is important to store this energy also. So there are many techniques by which they can be stored. Okay, so which is important, which can help us, in having a constant, regular supply. So there are molten salts, there are phase change materials, reversible hydrides, fluids. These can be used. Okay, so there are just showing, people have used it in many countries like USA, France, Spain, and it is kind of a very promising technologies that can be used. Okay, so on-site renewable energy, we can go for not only solar, wind, then second generation biofuels, they can be used. Okay, as you can see, this is all agriculture waste which can be used for generating this. Then geothermals, I've already spoken of that. So net zero building, we're talking. Okay, net consumption is zero. Okay, so these are all elements of an energy efficient building and intelligent building. As I said, automations, controls, they will also always help. Okay, so just quickly, just let me show you this turbo building. When it was built, it achieved 60 points out of 69 points. Okay, and basically what they did was their air conditioning was solar powered. Their dishes had the ability to track the sun path. Okay, so that's how they achieved with good daylight. They were reduced the 25% energy consumption was through renewable. Okay, this is the Shorabji building CII in Hyderabad that I spoke of. That was the first green building in India. Okay, platinum rated. Okay, so this has, if you go to Hyderabad, I think a very good building to see. This is the ITC Center in Gurgaon, one of the first building that I'm talking of. Okay, so they also had a lot of energy efficient features. This is another VIT park in Hyderabad. So they also did a lot of things about energy savings. They had 15% there. Okay, apart from other aspects which I'm not going right now. Another building in Chennai. Okay, so they also did Wipro Gurgaon is another one of the early buildings. Okay, so they also had a lot of things. This is a skyscraper of Mumbai. Okay, Antila. Okay, so this is also a green building. Okay, covered with foliage all around. Okay, this I'm showing example. I earlier spoke that these as CSR, big companies are also looking into how much they're impacting the environment. I'm just showing one example because of some personal contact. Somebody has shared his data. Okay, so how a company, for a particular person, see how the company is tracking what is the carbon footprint of a particular person. Okay, how how much paper has been used, what the company is doing, what is the greenhouse gas emissions, how much tons per year because of power, because of business travel, daily commute. Okay, then what company is doing, rainwater harvesting, low flow toilets, low flow taps, all these kind of things. What the person can do, switch off the light, watch energy wastage, use energy efficient products, use ground transport instead of flying, plan longer trips instead of frequent short trips, use mass transit, carpool. So, all these things, if you can see, a lot of sensitization is coming. This is another example of Dubai Tech, largest green building in Dubai they are talking of. If you can see the twin buildings, how they are, tapping into the twin buildings, how one building is shading the other. Okay, so they're trying to do a lot of things. Sky farms is what is the future now. Since land is less, we are going vertical. Okay, doing farming vertical. So this is also one of the projects which are planned. Okay, so you can go there and see these. Even wind turbines, they can be used. Okay. So there are a lot of things that we can do, to stay in harmony with other species. Just a small example of India, Uttarakhand, how they especially built a very ecological eco-bridge, 90-foot long, so that this was in a forest. Okay, so to help reptiles cross the busy jungle road. Okay, so we can all do some good things also. All right, just showing some examples how someone in their home itself, they have 10,000 square feet of forest kind of they have done plantations in 35 years. How this example in Kerala where police is growing vegetables on confiscated vehicles in Kerala. So the options are so many. This is also one example, hydroponic farms. Fresh vegetables being grown inside the buildings and how they are being supplied. Okay, so nothing is impossible, friends. Okay, I'm saying this with this news clip which I saw. Astronauts on Moon, Mars may grow homes out of fungi. So if out of fungi, astronauts are planning to grow homes on other planets, then definitely nothing is impossible. So we have to understand that what we are doing to our buildings, and we have to be a little bit sensitized about it. Thank you so much. So with this, I will put a stop on my speaking.
Madam, you had before you had concluded your session and wide information you had thrust upon the all the participants from the heat, energy, electricity, and all green environmental concept. You had done a very excellent job. Now, I request participants, if even if after this much exhaustive presentation, if they have any questions in their mind, they can put before Madam. She will answer your questions. Or also put in chat box also. So, Madam, there is a question from our principal sir that what kind of research work going on in case of energy efficient building at NITTR Chandigarh? Our public buildings are constructed by following ECBC norms in Punjab state.
Yes, sir. I think a very good question. So, sir, as I said, in Punjab, the ECBC has been notified. So, all the new commercial buildings that come up, as I told you, the kilowatt and KVA requirement, if they're falling in that category, yes, those buildings have to comply with ECBC. It is required. So there is no escape from that. So, all the states which have notified ECBC, the buildings have to abide by. It is a law. So in Punjab, it is notified, sir, and a lot of things are being done. I think Punjab recently also got some award also for doing a lot of interventions in energy efficiency. So every state has a state nodal agency.
Yes.
Okay, so every state for Punjab state it is PEDA, which is the Punjab Energy Development Agency. So in NITR, we are in constant touch with them, sir. And as far as research is going, sir, our ME students, our PhD students, so we are working a lot on building simulations. So we have a lot of projects that we are doing, and also we are working on developing, green materials. Okay, so a lot of waste materials are being incorporated for, fly ash bricks, geopolymers. Sir, our students are developing. So we are working on a lot of products like even eco-friendly cements, concretes. We are working on a lot of these things. If we if sir we actually we would love if you come to our campus sometime. We would like to show you around what kind of we have good labs, and we have good students also, the kind of work our faculty is also doing. So definitely all your teachers, sir, and you're most welcome to sometime please visit us in Chandigarh.
Right. Thank you.
Yeah, thank you, madam. I know personally Punia sir. He was a director at TTTR
Right, sir.
Chandigarh, and we were together on UGC team
Great,
in
sir.
2 occasions. And last time I was before 4 years I was principal at College of Engineering Jalgaon. So that time our one student or two student work in that Chandigarh labs, and I have
Great.
taken external from your TTTR Chandigarh.
Great, sir.
That
Definitely.
that was a connection between these two colleges, and I hope at Nagpur we will continue to do so.
Definitely. So we always look forward if we can, combine the strengths of both the institutes and do something good for the society.
Your
And
continuous fluent English and mastery on the subjects really we have
Wonderful.
yeah, so much delighted actually, and I think your research area in this direction only, madam.
yes, sir. Yes, sir. My main my area is structural engineering, and apart
Yeah.
from that, like here I'm involved with a lot of this green buildings. So we are teaching this subject as a full-fledged subject to our ME students.
Right.
Yeah.
And we have very active IGBC chapters. We are having MOUs with PEDA, GEM, and everything. So we have a lot of student activities, inter-college, interstate activities, and students are doing thesis work, which is practically helping the industry with
Right.
industry problems.
But
So
now
we are working a lot in this area.
the curriculum of the university has not included all these items which we have discussed. Even in the green building, they will have only one paragraph about the green building, but there are many details about green building also itself.
Right, sir.
The people
Madam,
have
regarding these ACBC norms, few states are now they are practicing. What
Right, sir.
about the government of India's initiatives in this direction?
So basically, as I said, like what government has done, like it has given ECBC. Now each state has to implement it. So, sir, state-wise, there are many incentives which are given. Like, sir, state of Punjab, it gives more FAR if you comply with ECBC. So their processing is very fast. Similarly, there are examples. I think in Kerala also they are giving many incentives. So state-wise, all these state nodal agencies, they are looking into it that renewable energy is used and ECBC is complied with, and they give lot of incentives in terms of there are incentives like concessional solar panels were given in Chandigarh, especially so
Oh,
that to promote people that they go upward. So in Chandigarh, so if you come, you take a aerial view, you'll see many solar panels on the roofs of the residential houses also. So
yeah,
people are using that because I think India is a country blessed with sun
Yeah.
almost all 12 months. So this is
yeah,
something we can tap. Our coastal, we have such a beautiful long coastline, wind energy. We can do so much with it, tidal energy.
Right.
So definitely a lot of things. I think Gujarat, our prime minister's state. So there are so many things which have been done here. Some beautiful things to see how they have used tapped into wind energy. So the new highways which are coming up, sir. So
yeah.
they are doing rainwater harvesting. So along the highways, there is so much of we have a long road network in India. So along the roads, they are putting solar panels now. So that is being used for street lighting, being given as grid. So a lot of things are happening. We are seeing such nice highways, expressways coming up. Our metro stations, they are all tapping into solar energy. So whatever place we get, even sir, the new technologies which even India is adopting now, like Sweden, Netherlands, they already have it. So with the passage of tires on the highways, with the pressure they are generating energy.
Yeah.
So even India is adopting these kind of technologies.
Wow, very
So
good. Very good.
between the medians, there are high cars going in both the directions. So much of air circulation is there. They're putting small wind turbines there. That is generating electricity.
Hmm.
So a lot of things are being done, and even at our own ends, I think if we can educate our children, in our students with these kind of things by our own actions also, not only just telling them we should do it. So there is a lot of things. If the new generation can learn these things, it will be very good, sir.
Right.
Madam, your institute is autonomous. So how the BTech students they clear JE on that basis they admit
So
No,
we
or
don't
there is
take BTech. We are only for teachers training. So we have MTech and
tech,
PhD levels.
PhD.
okay, okay. So for
But our
MTech,
main mandate is teachers training.
so for MTech only the gate is the qualifying this thing criteria.
So we have Punjab University. We are affiliated to Punjab University. So we have a qualifying exam of Punjab University also, or we have
Yeah,
sponsored teachers also and sponsored
yeah.
industry people. They can also come with some qualification
Polytechnic
requirements.
QIP program is there, no?
Under
Is it?
QIP also, sir, we have a lot of students.
Yeah, Maharashtrians are so many faculties are undergoing this QIP program at.
Yes, yes, sir. We've had very good sir research scholars from Maharashtra. I've in our department itself when I joined, I remember.
Correct.
Okay, thank you very much.
All right, sir. Thank you so much.
There is one question, madam, ki what
Ji,
kind
sir.
of project should be carried out to save the environment? Please elaborate, ma'am. And how to
So
give
what?
awareness to the public? Same thing.
So what kind of
Project should carry out to save.
projects?
Project should carry out to save the environment.
So I think this is something so many things can be done, which Professor Ashok has asked. I think to
Yeah.
save the environment, projects can be like more. First of all, is awareness and education of people, which is the first thing. And definitely with the technology, we can do so much of things, coming up with new sustainable materials, having buildings, which are energy efficient. Simulations can help us a lot. This is one area, as I showed, building energy simulations. So these kind of things, how, energy, renewable energy, we can tap various sources. People are going for second generation, third generation fuels. Our campuses, how we can have green vehicles. So there are a lot of projects as teachers that we can, give our students on studies. People are talking of cyclic economy these days. So how we can have an economy where, we are talking of net zero carbon.
Yeah.
So no climate change. So there are lots circular economy people are talking of. So I think even in India, we are not behind. As teachers, we should push our students to think of these things. So a lot of things definitely can be done to save the environment. The opportunities are endless.
Right, sir. There is another question from Sushma that could we do any innovative thing for ventilation at WC bath duct, specifically in flat system?
Ma'am, specifically when you're talking of WC bar ducts. So what can specifically we can talk of is for ventilation. So definitely, if we can, plan out the whole building in a way wherein we can have some openings in the WC where we can promote ventilation. And as I said, with the shading and trees around that building, we can definitely promote more air inside that particular room that you're talking of. And definitely with the materials also, less heat ingress, what I feel you're specifically talking of the air quality here, I feel.
Yeah.
So, one thing, which I have personally also seen, indoor plants can do a lot of things. Indoor plants can do a lot of work to, purify the air and everything. So for ventilation system, definitely, as I said, how I place my fenestrations, that can help, trees around it. And even indoor plants are a very good thing.
Right, ma'am. So, ma'am, thank you very much for all the discussions we held after the session. You had done a very excellent job. Now I request Dr. Tekade sir to conclude the session with the vote of thanks.
Uh, Thank you, madam, for such a informative session on the green building and its aspects and components. From your session, we have come to know about many new things like about the green buildings. Also, you enlightening us about the 10 principle, a holistic approach to the sustainability. Then what is the purpose of building? What is meant by thermal comfort, living comfort, lighting comfort, then air quality, acoustic support. What is the difference between the conventional building and green building? Then after that, discuss about intangible benefits of green building. Then what are the properties of building envelope, thermal mass, HVAC, and after that software like building simulation type, which is very knowledgeable and useful for us. So thank you, madam, for sharing such a wonderful session with us. Lastly, thanks for accepting our invitation and sparing time from your busy schedule for guiding us on this topic. Thank you, madam. Thank you very much.
Thank you, ma'am.
Thank you so much to the organizers for inviting me. I have very thoroughly enjoyed this interaction with all of you today. And thank you all the participants for the patient listening.
Thank you, ma'am.
Thank you so much.
Thank you.
I will leave the meeting now.
Yes, ma'am.